Welcome to the Racing Medication and Testing Consortium's webinar, Controlled Therapeutic Substances, the How and Why of Thresholds and Withdrawal Guidelines. While the RMTC is equally engaged in identifying emerging doping threats, the focus of this presentation is on medication having legitimate use in the care of the equine athlete. This webinar will be archived and available for future viewing on the RMTC website. The mission statement of the RMTC has three prongs: to develop and promote uniform rules, policies, and testing standards at the national level, to coordinate research and educational programs that seek to ensure the integrity of racing and the health and welfare of racehorses and participants, and to protect the interests of the racing public. With respect to the regulation of medications having legitimate use in caring for racehorses, the RMTC's philosophy is to allow racehorses to receive ethical and humane care, to promote competition of sound, healthy horses, and to prevent medication from affecting a horse's performance and thus the outcome of a race. To begin, it is worth a quick review of the genesis of the RMTC. In December of 2001, the American Association of Equine Practitioners hosted the Racehorse Medication Summit at the annual Symposium on Racing in Tucson, Arizona. The summit organizers brought together individuals representing a broad spectrum of organizations across all racing breeds for a facilitated closed-door meeting to determine potential consensus points on the most basic elements of a uniform national medication policy for racehorses. At the conclusion of the meeting, the attendees vowed to continue the effort beyond the Tucson meeting, thus leading to the formation of the Racing Medication and Testing Consortium. In recognition that the sensitivity of current drug testing methods allows detection of many legitimate medications long after they have been administered, it is necessary to enact regulatory thresholds. Thresholds establish a consistent laboratory performance standard and protect stakeholders from variations between laboratories. Corresponding withdrawal guidance must be developed so that stakeholders understand how to comply with medication regulations. The following is an explanation of the scientific approach used by the RMTC in developing uniform regulatory thresholds and withdrawal guidance for the use of essential therapeutic medications in the racehorse. There are 6 steps to the process. Number 1, identify medications warranting thresholds and withdrawal guidance. 2, facilitate administration studies through designing, funding, and/or executing relevant studies. 3, develop analytical methods and perform sample analysis. 4, analyze the data. 5, formulate threshold and withdrawal guidance. And 6, educate stakeholders. Step number 1, identifying medications warranting thresholds and withdrawal guidance. The RMTC solicits input from American Association of Equine Practitioners member racing veterinarians to understand what specific medications they consider necessary for the ethical care of racehorses. In 2001, AAEP members were surveyed to identify essential medications. That list served as the basis for what is now known as the Schedule of Controlled Therapeutic Substances. AAEP members were surveyed again in 2011 to identify new or additional medications warranting threshold development. In 2012, the RMTC convened a panel to deliberate on the use of corticosteroids in racehorses, and included were AAEP member racetrack practitioners, surgeons, regulatory veterinarians, pharmacologists, internists, and chemists. The RMTC solicits input from the AAEP Racing Committee on a regular basis. This table lists the medications most commonly identified in the 2001 survey. Survey responses included dose, route, and frequency of administration, and justifications for use. For some substances, the responses were highly variable, reflecting individual practitioners' specific preferences and not necessarily consistent with manufacturers' recommendations. This is the 2001 list, with medications having thresholds and withdrawal guidance highlighted in green. Anabolic steroids are highlighted in yellow as they are no longer considered to have therapeutic use and thus have been regulated differently from the other medications. In addition, the RMTC developed thresholds and withdrawal guidance for diclofenac, marketed as Surpass Cream, and thyrocoxib, marketed as Equiox, as both these NSAIDs have received FDA approval for use in the horse. This is the 2001 list with medications highlighted in blue that were not identified for threshold development. It is important to note that these medications are not prohibited per se. Veterinarians are legally able to possess and administer them to the extent that they are allowed by state and federal law, but there is no guidance available with respect to their use. The regulation of these medications may vary substantially between states, and there is unknown risk when they are administered in proximity to a race. So why were these medications excluded from the schedule of controlled therapeutic substances? For some, threshold and withdrawal guidance already exists for substances with similar pharmacologic effects. In some cases, the use of the medication in relative proximity to a race is philosophically objectionable. For others, there is no evidence for a therapeutic effect, or FDA approval has been withdrawn. The list of controlled therapeutic substances is intended to provide medication options when veterinary treatment is needed in proximity to a race. This list will be revised as needed based on the release of new veterinary medications, evolution of usage of existing medications, or new or additional science. The RMTC Scientific Advisory Committee communicates regularly and convenes twice yearly. Current membership is listed here and includes regulatory veterinarians, active racetrack practitioners, veterinary pharmacologists, and laboratory directors. Collectively, these individuals have over 300 years' experience in horse racing and its regulation. The Scientific Advisory Committee, in considering a medication for threshold and withdrawal guidance, contemplates the ethical indications for its use, risks posed by the legitimate or illicit use, implications for equine welfare, whether FDA approval exists for the horse or other species, potential to affect athletic performance, the associated penalty classification, the existence of threshold and withdrawal guidance for a similar medication, and the RMTC's philosophy of medication regulation as it pertains to the specific substance. Once a substance has been identified, the RMTC Scientific Advisory Committee will make a determination of appropriate study doses, routes of administration, and duration of treatments through consultation with the AAEP Racing Committee, manufacturer's label instructions, veterinary clinical journals and textbooks, practicing racetrack veterinarians, particularly with respect to conventional off-label use, veterinary pharmacologists, and internal medicine specialists. Step 2, facilitate administration studies. Before any administrations take place, the Scientific Advisory Committee reviews existing information related to the medication, data, published and unpublished, as is available, and identifies ongoing research, both domestic and international, to avoid redundant research efforts, and identify opportunities to collaborate on administration studies to maximize the value of research dollars available. Even when regulatory philosophies conflict, data derived from well-designed studies can be analyzed, and threshold and withdrawal guidance can be determined relevant to the individual authority's needs. There are 3 basic types of administration studies, each with a different goal. Pharmacokinetic, often referred to as PK studies, elimination studies, or abbreviated PK studies, and pharmacodynamic, or PD studies. The pharmacokinetic study examines what the horse does to the drug. Study goals include determining how a substance is absorbed, distributed, metabolized, and eliminated over a period of time. A typical PK study involving 16 horses and using a single dose of medication with a targeted 48-hour withdrawal interval will involve the collection and analysis of more than 300 blood and urine samples at a cost of approximately $30,000. If the laboratory must also develop an analytical method to detect the substance at relevant concentrations, the overall project cost can increase by approximately $15,000. The elimination study, or abbreviated PK study, has a more limited study goal: the determination of a concentration relevant to a specific point in time. The study design involves substantially fewer samples per horse than is required for a full PK study, as sampling brackets a targeted interval. Typically, an elimination study will include more horses than would be used in a full PK study. The pharmacodynamic, or PD study, examines what the drug does to the horse. This type of study is often used in preclinical drug trials measuring drug-receptor interactions or physiological reactions. These studies are highly complex and contain multiple inherent problems that can confound regulation. Many medications affect multiple systems: the respiratory, cardiovascular, neurologic, gastrointestinal, and/or musculoskeletal. Therefore, there can be multiple effects from the administration of a single drug. It is not uncommon that those effects may have a greater potential to affect the performance than the intended effect of the drug on the target tissue or system. Let's use antihistamines as an example to further clarify this complexity. Antihistamines are administered with the intent of managing allergic conditions. However, there is also an unintended effect from their administration: drowsiness. So with respect to the regulation of antihistamine use in the racehorse, should the PD study examine the anti-allergy effects, or mental alertness, or both? Of the three study types, the predominant focus of the RMTC is on pharmacokinetic studies for determining an appropriate threshold after the RMTC Scientific Advisory Committee has made a philosophical determination for a withdrawal interval, typically dose and route of administration specific. PK study design requires determination of dose, route of administration, for example, intravenous, intramuscular, intraarticular, or oral, and frequency of administration. The number of horses to be treated is determined, and every effort is made to have the study population comprised of exercised horses of racing breeds and ages managed under consistent conditions. It is also necessary to determine which matrices, blood and/or urine, will be collected and at what frequency and intervals post-administration. Before the study can proceed, adequate funding must be secured for the administration and collection phase and subsequent analyses of samples generated. A suitable research herd must be identified. While some have suggested that the use of actual horses in training for these studies, the presence of multiple additional variables, ranging from the co-administration of other medications to variability in exercise frequency and intensity to coexisting health disorders, makes data generated in this manner virtually uninterpretable for developing a threshold. To select a laboratory to perform the analyses, the RMTC uses a competitive bidding process to ensure that research dollars achieve their full value. The RMTC issues a request for bids that clearly describes the work to be performed and requirements with respect to data sharing and publication. Only RMTC accredited laboratories are eligible to bid on the work. Laboratory accreditation, why it matters. RMTC accreditation ensures that each laboratory is capable of testing to the same level of proficiency. The accreditation process includes a site inspection and review of documented laboratory processes. This inspection is performed by an independent, internationally recognized racing chemist who has no conflict of interest. Laboratories also receive quality assurance proficiency samples twice yearly. Any deficiencies noted through the analysis of proficiency samples must be remedied by the laboratory and to the satisfaction of the RMTC's Horse Racing Testing Laboratory Committee. RMTC accredited laboratories are also required to perform research and share their results. Examples of research could be the development of an analytical method to develop a new doping threat or analysis of samples from administration studies. To date, the RMTC has spent in excess of $2.5 million on research into therapeutic medications, anti-doping, and strategic investigation of emerging threats. Here are some examples of the completed research projects funded by the RMTC. A complete list can be found on the RMTC website. Step number 3, develop analytical methods and perform sample analyses. In order to perform the targeted analysis for a specific medication in research samples, the laboratory must develop the analytical method. To do so, the laboratory must demonstrate that it can unequivocally identify the substance or its metabolites in equine biological samples, typically blood and/or urine, at relevant concentrations. Further, the laboratory must validate the method by demonstrating that its analytical results will be repeatable and consistent when performed over time or by different personnel within the lab. Following method development and validation, the laboratory can perform analyses of the study samples. A percentage, and in some cases all, of the samples are also analyzed by another laboratory to ensure that the method is transferable to other labs and that interlaboratory variation is minimal. Step 4, analyze the data. The individual data for each horse are graphed at each sampling point. Inter-horse variability is examined. Multiple statistical calculations are performed to identify how the drug is distributed in and eliminated from the body. Step 5, formulate threshold and withdrawal guidance recommendations. The 95-95 tolerance interval calculation is performed when the drug is present in measurable concentrations at the desired time point. This calculation can be applied to calculate the drug threshold concentration when the withdrawal interval is predetermined, or can be applied to calculate a withdrawal interval when the drug threshold has been predetermined. The following slides demonstrate the 95-95 tolerance interval as applied to administration study data to determine a regulatory threshold that corresponds to a 24-hour withdrawal guideline. The table displays the raw data from 20 horses samples collected 24 hours post-administration. The values range from 0.1 nanogram per ml to 20.0 nanograms per ml. It is not at all unusual to see such a broad range of values at a single time point. All of the values are considered to be valid. None are discarded. The mean, or average concentration of the 20 samples is 3.6 nanograms per ml. The standard deviation, which is a measure of the distribution of the values in relation to the mean, is 4.596. In this slide, the values from the previous table have been plotted on a graph, where the height of each bar displays how frequently that value occurred in the 20 samples. Note that the one sample at 20 nanograms per ml stands alone, well to the right of the others. The bell curve is probably something you remember from grade school. When data are normally distributed in a bell curve, as is shown on the left, there is a fairly even and consistent distribution on each side of the apex of the curve, which represents the mean value. The raw 24-hour administration study are plotted on the graph on the right and more closely resemble a ski slope. In order to perform the 95-95 tolerance interval calculation, it is necessary for the data to be normally distributed. So the 95-95 tolerance interval calculation cannot be applied to the raw 24-hour data. The data can be converted by applying the same formula to each. This preserves the relationship between the individual values. Typically, the data are converted to natural logarithms, although other conversions could be selected. Regardless of the conversion performed, after the 95-95 tolerance interval calculation is completed, the conversion is reversed to produce a normal number. This table displays the raw data in the middle column and the log converted data on the one on the right. The mean of the log converted data is 0.42979, and the standard deviation is 1.50102. The left-hand graph displays the log converted values by frequency. Compare that to the graph on the right, displaying the raw data by frequency. The distribution of the log converted values more closely resembles a bell curve, and thus the 95-95 tolerance interval calculation can reliably be performed. The 95-95 tolerance interval equation adds the mean to the product of the standard deviation and the K-factor. The K-factor is a predetermined statistical constant based on the number of study animals. The K-factor increases as the number of study horses decreases. What is the importance of the K-factor? The table displays the raw 24-hour data, but if only values from horses 1, 6, and 11 were available, with no consideration for normal variability beyond those numbers, you can see that a threshold based solely on those numbers would be unreliable and could result in unfairly penalizing those who did not comply with the 24-hour withdrawal guidance. The K-factor corrects for the variability that occurs outside of the limited study population. This table displays K-factors for studies with 2 to 20 animals. For a 6-horse study, the K-factor is 3.711. For a 20-horse study, the K-factor is 2.396. Going back to the 95-95 tolerance interval equation, the mean of the log-converted data, 0.42979, plus the product of the standard deviation, 1.50102, multiplied by the K-factor for 20 horses, 2.396, equals 4.02623. The log conversion is reversed. 4.02623 becomes 56.049,83959. The value of 56 is automatically rounded up to 57. In no case does the RMTC round down. Further, in consideration of the need for laboratories to prepare solutions of internal reference standards for use in the analysis of official samples, the RMTC Scientific Advisory Committee would likely revise the threshold recommendation to 60 nanograms per ml. Plotting 57 and 60 on the distribution graph of the raw data, you can see that they represent a threefold increase beyond the highest measured value. There is a substantial margin of safety in thresholds calculated in this manner. Some individuals erroneously declare that the RMTC's application of the 95-95 tolerance interval results in a 5% risk or a 1 in 20 chance of a violation when withdrawal guidance is followed. This is patently untrue and can only happen if the calculation is incorrectly performed by omitting the log conversion. Here is the 95-95 tolerance interval calculation performed on the raw 24-hour data. The mean, 3.6, plus the product of the standard deviation, 4.596, and the K-factor, 2.396, equals 14.61. This calculation would result in an incorrect threshold recommendation of 15 nanograms per ml. Going back to the distribution graph of the raw 24-hour data, it is clear that one of the 20 horses had a concentration greater than 15. Using the unconverted data to perform the 95-95 tolerance interval is incorrect and represents an unacceptable level of risk. This demonstration further emphasizes the importance of the log conversions and the margin of safety they provide to those following the withdrawal guidelines. Both graphs display the distribution of raw data. In the top graph, the red box indicates the incorrectly determined threshold. In the bottom graph, the red box indicates the correctly determined threshold and the one that would be the RMTC's recommendation for this substance. It may be necessary to consider other legitimate methods to develop a threshold recommendation. When there are no values in the study samples above the laboratory's known lower limit of detection at the selected time point, the 95-95 tolerance interval calculation cannot be used. It may be necessary to evaluate urine values at the desired time point, or the laboratory's lower limit of detection value can be recommended as the threshold. The establishment of a specific value eliminates the risk associated with zero tolerance when there are variations in the detection sensitivity between laboratories. A numeric threshold establishes a performance standard for the laboratory and ensures that horsemen are protected from overly proficient laboratories. Just a few words about peer review. Peer review is a term that is often heard but may not be well understood. Most scientific journal articles are reviewed by 2 to 4 independent individuals having competencies relevant to the subject matter. RMTC administration studies are reviewed by all 16 Scientific Advisory Committee members. This results in a broader scope of scrutiny than that applied to most studies published in peer-reviewed journals. the addition of practicing and regulatory veterinarians to the review process helps ensure content is relevant to end users of the information, those administering the regulated therapeutic medication. It is the RMTC's goal that all the research it funds be published. However, the interval required for publication may subvert the goal of promptly developing threshold and withdrawal time recommendations. In some cases, the research is published after the adoption of a threshold. Returning to the process, the RMTC Scientific Advisory Committee reviews the data and the results of the 95-95 tolerance interval calculation. The Scientific Advisory Committee considers the calculated value, always rounding up. If the upper limit of the 95-95 calculation is 30.1, the minimum threshold considered by the Scientific Advisory Committee is 31. The Scientific Advisory Committee may further increase its threshold recommendation based on laboratory considerations. It is likely that a 95-95 tolerance interval value of 31 would be rounded up to 40 to facilitate the laboratory's need to prepare serial dilutions of reference standards for the analysis of official post-race samples. Information describing the Scientific Advisory Committee's efforts is presented to the full RMTC board that then considers the threshold and withdrawal guidance recommendations. The RMTC board is comprised of a wide spectrum of stakeholders, including representatives of breed organizations, racetracks and racing associations, regulatory authorities, equine veterinarians, owners, and trainers. This is the current list of member organizations and their representatives. The RMTC board forwards its recommended threshold and withdrawal guidance to the Association of Racing Commissioners International with a recommendation to adopt them into the model rules. Step 6, education and outreach. The RMTC website has information on the National Uniform Medication Program, laboratory accreditation, research, withdrawal times, ARCI rules, and much more. A monograph series on the controlled therapeutic substance is being prepared. Over 1,000 copies of the RMTC's Cobalt brochure have been distributed. Dr. Benson and other members of the RMTC Scientific Advisory Committee routinely present at veterinary continuing education meetings. On behalf of the RMTC, Dr. Benson makes presentations to industry organizations, participates at commission meetings, conducts continuing education for the Racing Officials Accreditation Program, and interacts one-on-one with stakeholders. Additional information is available on the RMTC website at www.rmtcnet.com. If you have questions or to find out how you can help, feel free to contact us at 859-224-2844 or contact us at rmtcnet.com. Thank you.